Raised by Gen X Garage here. Here's part 2. And let's proceed with the video right now. Measure from this to that inside lip. So what I'm going to do, like I said, I measured from this to this screw hole. So that is 300 thousandths, I believe. Yeah, I'm going to make it an even 300, or I could do 290. That would give that a little bit more structural integrity. It's only by 10 thousandths. And I don't have to go clear to 290 to 300, but I can. So why not? I can, it gives me more practice. So what I'm going to do is I'm just going to cut this lip down to might as well just do, I'm just gonna make it, let's say, just say I'm gonna make the lip 200. That'd give it an extra 100 thousandths to, extra 100 thousandths for strength. Anyway, so on here, so I'm gonna work on that inside bore here, and I'm gonna get this set up. I'm not going to bore you with the process of setting this up, even though I should for educational purposes. But at the same fact, does anybody really want to see that? Maybe, maybe not. But on that note, let's just do this and say this up here. My zero is, I don't have feeler gauges, so, well, I do, but I don't know where they're at. Or a 1,000th shim. If I had 1,000ths, I would set that, see, like that little, see how it cut a little? I'm gonna set this dial indicator, this little screw here. I don't like these dial indicator setups, but it's what I got, and it makes it for a good challenge, because I'm not used to those. So I set that to 0. This is to 0, which is the face. I'm going to move that 10, or 5, I guess. At some point, I'm going to move that 5 and face it again, but not at this point in time. What I'm going to do now is turn it on, make sure my feeds are going in the correct direction, and cut from this little ring here in until I hit said 200 thousandths, and then when I hit that point, I'm going to decide, do I want to go a little bit more, or do I want to stay the same? Because this lathe is set up to where the belts are wore and everything like that, and it's been converted, let's just say redneck converted to single phase power. It was originally a 3-phase power machine, and I got this, or I think it was my old man that got it. When he got it, it was already converted to this. All he had to do was plug it into power. Same thing with that. Most of these lathes this size and bigger are 3-phase power, and I don't know how to explain 3-phase power. I just know it's a lot more power than single phase. Like most houses and everything, that's single phase power. Like big manufacturing plants, they have 3-phase because they have big machines. Like this is small machines here, but they have big machines because the simple fact of that's what the motors are. If you want to know more about 3-phase, just go on your Google machine and look it up, because I'm not going to sit here for 3 hours and try to do research about 3-phase power when I really don't need to do that. So I'm just going to run this and see what happens, because what I'm going to do, I'm going to move this here, which is the, I don't know, it moves this side to side. This one moves it into out. See? Moves the technical names I forget because it's weekend. More or less, it's, I don't know. I just don't want to feel like sitting here and explaining it. I could, but I'd be here for 3 hours trying to explain how to work this machine, and I'm not going to. Simple fact of, I'm going to do that until that needle down here, this little one, goes clear over to 2. I'm going to decide, do I want to go 2 on this little and 0 up there. If I can, that'd be great. So I'm going to start that, and then here in a couple seconds, while I have this running and I know all my feeds are good and all that, speeds and feeds, that's how you get the finish that you would like on the material. Even though I'm going to sand this and possibly polish it, I want to try to get the smoothest finish that I can with the machine. Smoothest and, well, prettiest, if you will. I want it to, what my final product is, what I want it to be, is about something like this, minus via silicone and other things on here. Like tarnish on the inside and broken. Honestly, I'm pretty sure all this needed was that seal right there replaced, but I'm going to see if I can make a new one. If I can, great. If not, I tried. And that's all that matters. Because if I try and fail, well, I learned, or hopefully, I learned from my mistake. Nice thing, it's not a, let's say, $100,000 part that needs to be done yesterday. I can take my time and actually pay attention to what I'm doing, which is awesome. It's something I like doing. As long as you work steadily, you will get somewhere. If you don't work at all, you're not going to get anywhere. If you work a bunch and burn yourself out, yes, you'll get places. You'll get there faster. But you'll burn yourself out and you won't want to do anything. Okay, so I'm cutting this. My feed might be just a tad bit too fast. But, and that isn't set right because that's supposed to be breaking off, not being stringy. I guess that's what stainless does. I guess I didn't think about that. But anyway, also, you should never do this in playing with chips on a lathe. Some of the stuff is really sharp and hot, like that. That is kind of warm. It'd be self-explanatory. Also, in a machine shop, you want to think everything is sharp and going to kill you. Like that. That is making a weird frequency. So I'm going to change the feed, well, the speed of the feed rate, because I don't think I can change my tooling and still get the same area where I need to. I'm going to let this finish cutting and then I'll kind of paying attention to more of my work than I am where the camera is pointing. And that sound is really annoying. I don't know if that is the machine or me cutting the material. It's away, so I would assume that was the belt squealing for life. So what I did on this cut, I only took a 10,000ths cut because it was set at 0, which is this face here. You step in, which is the 10,000ths. So what I would do, move this back out far enough that I know I'm going to clear, move this back out to where I need to, and then make the feeds slower. I don't remember how to do that. Well, I kind of do, but I don't remember the exact speeds of everything because the table here don't tell you much. I mean, I guess this does, but that's just kind of, I guess, I don't know what you would call it. Your table for speed, I guess. I mean, that's your threading chart, hence why it says threading right there. So I'm going to guess this is your speed. So what I want to do, it was set on D and 8, right? Yeah. So it was set on here at 50. It was set over here at 56. So I'm going to slow it down to this. Yeah, I'm going to slow it down to, let's say 40. So I would take it, I'm going to take this little lever here, go over to the D slot, and then go up here. So that's 4. So I'd go over here to 4. So now we should be set at 40. And if it does that squealing thing again, I will slow it down more. And all this does here is control the this is the threading screw, this is the feed screw, or yeah, I guess it's feed screw. The feed rod per se. So I slowed that down. So this in theory should be slowed down. So what I can do is I can come up here, I can look, and wherever that is, since I got a little taper there, I can set that. Now if I turn it on, it won't cut anything because it's that 10 on that dial. So what I need to do is I need to move the compound here 10 more or 20 thousandths in while it's on, and run it again. So when I get this close to where I need to be, I will be back, or I'll just time lapse it. I don't know. I figured out. Now I probably should time lapse it because that'd be the smart thing to do, and to show you guys the process instead of in real time. Definitely probably should time lapse it, but I will figure it out. And if it is time lapse, it'll be in a clip here in a second. If it's not, well, it'll just jump to the nice clip of this already being machined. Okay, so I figured out what worked better in this situation. I was going from the outside in to cut, but apparently going from the inside out is working better. So I'm going to continue doing that. Who would have thought? I might put in a boring bar and try to cut that way, but there ain't no guarantee that it'll work better. Or just straighten out my tool and my tool post. So I quit getting this, because this is dangerous. Let's get a watch. Actually, let me stop that. Never grab chips with your hands. Always use some sort of pliers or something along those lines. Be smart about it. Be really, really, really smart about it, because they can and will cut you. But I think I need to change something. Feed rate, I guess. Let me try that. I had it at 40 here, so I'm going to turn it down to 36, which would be, if it'll let me here, which would be D2, which I have it set at D and 2. I'm going to try that and see what happens, because I don't know what will, or if it'll become good or bad. Hopefully good. Okay, so it's kind of trial and error here. Seeing what works the best. I had to change the tool post degree. I think that's what it's called. Anyway, I had to rotate this to accommodate the angle in the tool. So we'll see how far off it actually is via the dial indicator. So if I go, I think I'm close, actually really close to touching, which is wonderful because I didn't want to, yeah, see, okay. So, yeah, we're only 22 thousandths away from actually where I needed to be. Oh, that guy must have got dropped and cracked the lens. But anyway. So I'm going to try this again and see if I can somehow manage to, because I think I have cut roughly, yeah, I've cut roughly 80 thousandths out of it. And I need to go to, what did I say, 250 or 290? I'll go to 250 and decide from there. I think that's what I said earlier. It's pretty much dark now. I started this at like, what? Started this about 4 hours ago, and yeah, this is how far I've gotten. Yeah, running around is not, you can't get stuff done when you're running around going several different places. You can, however, get stuff done when you consistently work on it. Big shocker how that works, isn't it? So 80, I'm going to go in and then go to, I think we should be able to do a 20 thousandths cut and be perfectly fine. So it was at 80, so I'm going to go to 0. Start it up and run it and see what happens. Yeah, I'm not going to bore you with this. I'm going to, I'm just going to come back when it's done cutting. Or start a time lapse. Probably just do that. So I'll just be back when I'm done machining this, because you saw a little bit of the process and there's going to be a lot of that. So finish that cut, move it a little. Finish the cut, move it a little. And repetitive until it's done. So that's what I'm going to do, and then I'll be back and show the finished product of this depth cut. Okay, so I ended up doing something a little more different than what I normally would do. So this is what I ended up doing. Normally what I would do is I'd take this depth here, clear out to here. But that is at 250 thousandths, which is 1/4 inch. In case anybody was wondering that. Don't know if you were or not. Can't read your mind. Can't see you. Really appreciate if you would, hit the like button if you enjoy this content. If not, leave some content suggestions in the comments. I'll try to read them and get to them. But anyway, back to this. So normally what I would end up doing is I would try to mimic the original here. But that being on the inside to where the sits like that on top of the cab. Nobody's gonna see that. So why make it like the original one when nobody's gonna see it? And plus, in here, I need to bore out or drill out to fit the bushing. And also the leather seal that goes on the bottom side of this. Which I think, if I'm not mistaken, this bushing here, I mean, yes, it's a split bushing, but, I thought it was cracked for a minute on the inside, but it is not. It's just how it looks. See those lines inside of there? I thought those were cracks. They're not. But what I'm going to have to end up doing... Here's the old gasket. I'm going to have to end up setting this out here. Oh, that outside is way too big. I'm going to have to end up setting this out here. And marking the holes, which is this one, that one, and that one. I don't know why there's 4 other holes in this, but I'm going to even start there. But get those and mark them on here. But what I need to do is I need to get the OD outside diameter the same as this one. And now I haven't measured this. Probably should. But anyway, measure the distance here, which I think looks like 3/8. Measure the distance here, and then mark it on that with said tool. And then machine it down to what it needs to be. And then what I can do is take this out, flip it around, take it from this to where this cutout here is on the other side, and then finish machining this down. But if I'm not mistaken, that should be somewhere around 3/8. But I'll measure it, I'll come back, and I'm going to use the calipers, not the micrometers, for the simple fact of this is tapered, plus this thickness doesn't really need to be that accurate. Now when I go to do the internal diameter here, ID, yes, I will use snap gauges. I will clean this up to get measurements. Actually, I'll probably just get measurements off this, clean up the bushing right there, and see if cut it, make sure that it fits this. But I want it tight enough tolerance to where everything goes in and it's sealed with tolerance, not only with leather and said bushing. I would really like it to be with a tolerance seal. So I'll probably end up making the, well, that's already where it needs to be. This bottom one here is the same. It's actually this bottom little step here. I'm going to make it the same diameter as what the, not the same, but a couple thousandths bigger than the shaft that the light is attached to. So if I can do that, that would be awesome, which I'm confident I will be able to do that, and I will get it done. But being that, this video might have to have a part 2, because part 2 as of part 1 uploaded tonight or tomorrow, and then part 2 uploaded tomorrow, which I might end up doing. You know, I might just end up doing that instead of trying to make all this video in one night, because I won't be able to, one evening I should say, I won't be able to drill those holes tonight. Mainly because I need to find everything, and I really don't want to find everything tonight. So I'm going to measure the OD, the entire OD of this bracket here. So from my pointer finger to my thumb here, measure that, get the, which the stainless is warm, get that the same diameter as this, and then run with it. Because the only, honestly, the only critical measurement that is on this is this, where the shaft goes through, the center here, where the bushing and leather seal go. That's honestly the only critical part. The rest is kind of, I have a bunch of leeway. Honestly, I could just leave this way, but it's me being me. I don't want to leave it that way. So what I'm probably going to end up doing is changing my cutting tool from this 60 degree to whatever you want to call this. I don't know what it is. it's more square and less chatter and stronger. Which looks like I need to change out the yellow thing there is the insert. Change that out. Or go find another one, which I have somewhere around here. I don't know where. Well, here's another one, but it's not much better. They're both about the same. So I'll go find my, I know I have a third one around here somewhere. Go find that one and turn the OD of that down, and then I'll be back. And probably part 2. I'm guessing part 2.